Terry Griffin is a associate professor in specialist in ag economics at Kansas State. He has been working precision ag for at least 30 years, and I think cut his teeth. I think he did his PhD on-farm experimentation, and he's going to give us a quick view of some of the difficulties and realities of making the technology work to enable us to generate value from the OFE. So, Luis, I think we're over to you, if that's okay, to screen Terry's pre-recording.
Hello, I am Terry Griffin. I'm on faculty at Kansas State University.
Looks like we're
I
about to
appreciate
go
Simon
with Terry.
Cook for inviting me to participate. I'm going to be presenting on from commercialization to realization. How can we empower the farmer rather than hinder them? And this is part of the on-farm experiments series we have today. So first, let's take a look at the adoption of technologies over time. Specifically, this is for the state of Kansas. This is data coming from the Kansas Farm Management Association, which is a group of about 2,000 farmers today who are part of a record keeping and benchmarking cohort analysis group with electronic records going back to the 1970s. 5 years ago, when I arrived at Kansas State University, we started asking some questions in addition to the traditional financial and production data that were being collected from the KFMA farmer members. Specifically, we asked the farmer, what technology do you have on the farm? When did you adopt it? And if you disadopted, when did you stop using the technology? And I want to draw your attention to the two most commonly used technologies in the current time period. These two here, they're in blue and light blue. And the first word in their names is automated. That is not a coincidence. So one of the themes I'm going to talk about today is automation. And historically, we in society have been really good about automating tedious things like digging ditches. And here we've automated the process. Automated guidance has automated the process of making parallel lines in a field, which is great. But we've automated something that we generally have paid very low wages to do. And the things I'm going to talk about today are bordering on replacing higher wage management labor or analysis labor that come from all of the above, not just automated guidance technologies, automated section control, but especially yield monitors and grid soil sampling and variable rate technologies. So if you think about the timeline of those technologies when they were commercialized, it gets really fascinating. One, the technologies based around sensors have been around a lot longer than automated technologies. Looking at this graph, we can see that automated guidance was commercialized in the late 1990s, automated guidance more recently, but it's been 15 years ago in 2006. So the sensor technologies have been around a lot longer than technologies that have been more readily adopted, the automated technologies. And for a point of reference, I do a lot of work with humans in the social economic aspects of adoption of technology. And I've added the secondary timeline here, which is the age of a young baby boomer or an older Gen X member. So the cutoff was about 1965 for birth year. Baby boomers were born between 1946 and 1964. And Generation X was after that. They were born 1965 to 1980. So in the 1990s, when yield monitors and GPS, global navigation satellite systems were becoming available for civilians, the baby boomers were younger. They were in their 20s, 30s. Also on timelines, I wanted to show this real quickly. I have an interactive timeline that we've added to the agmanager.info website at Kansas State University. Here's the long URL, as well as a shorter one that for developmental purposes. It's interactive and also it's a work in progress, but I just wanted to share that in case you wanted to play around with seeing where I thought different technologies were, uh, where they became commercially available. One of the technologies here that I have on the list is telematics. It is something I'm going to come back to. It's come on about 2010, about a decade ago. So, as far as automation, we talked about for this series, today we're going to talk about value creation, sharing. Well, first thing that comes to my mind is automation of data transfer and management. Okay, so with telematics, it's been around for about a decade now. There's the telematics data standard from the AEMP became commercially operational in October, November of 2010. So that's roughly a decade ago. Think about John Deere 20 series tractors and pushing data to the cloud. And when we automated, I don't want to downplay the importance of this. Um, the automation part sort of displaced moving thumb drives and other flash media between farm equipment and a desktop computer, but that is not necessarily a trivial task, even for research technicians who are trained to do so. The telematics, pushing data to the cloud, and so forth, opened up a lot of opportunity, not only for the farm, but there's a lot of other players who are suddenly on board, who are trying to intercept, utilize this data. Uh, One thing about data management is farm data are messy, and in particular, yield monitor data has been messy. So before 2004, I was in graduate school, and I hate to admit it, but when I was trying to clean yield monitor data, I was using spreadsheets. Very was not consistent methodology. Lots of problems with it. In 2004, my life got a little bit better, and USDA ARS, I became familiar or acquainted with yield editor software. And several years later, they had an improvement, and they've added something called the automated yield cleaning expert. And that's the screen on the right has take automated options for the user. So instead of the user spending 45 minutes or so per field to clean it, they had an option of doing a batch processing or at least interacting with the graphical user interface to identify and remove outliers. Big step in the automation, but that wasn't the end of the story. We're still getting opportunities. A few years later, 2014, which is almost a decade again, there was some proprietary cleaning algorithms that were commercialized in different software platforms. And last year, a lot of the academics got together and created a new NC North Central 1210 Frontiers and On-Farm Experimentation. And that's been one of our core ideas is how can we create better automated tools for cleaning and processing and managing the farm data. And all of these are sort of required in order to push the ball forward because these are very tedious and current skill sets are rather expensive. And one more thing about farm data that's been a barrier, a lingering barrier, is that there's been no version control when it comes to farm data. Going back to the yield editor example, if I receive data from someone who used yield editor and other software platforms, by the time the data gets to me as the analyst, I have no idea of that chain of custody. I have no idea how that data had been manipulated before it came to me. So, one of the questions that has been posed by my colleagues and I as an intermediate solution to this problem, can we use distributed ledger technology? This kind of the blockchain idea. And our paper that we had published earlier this year was three digital agricultural problems in cotton solved by distributed ledger technology. And I invite you to take a look at that. It's available online. And we discussed this concept of chain of custody quite a bit, and it's really an intermittent opportunity instead of version of control until a true version of control is available in agriculture for farm data. Getting back to this concepts of automation, and one of the big weaknesses that I've been working on for quite a while is this concept of analysis interpretation. Okay, so I think there's going to be a huge paradigm shift, not just in agriculture, but in other industries as well when it comes to analytics and data. So the old paradigm has been I download data onto my laptop and I analyze it in a spreadsheet or maybe with statistical software. The new paradigm is the opposite. I need to develop analytics and move it to the data. And as an analyst, I'm sort of at a disadvantage because I will never have seen the data. I need to develop analytics to analyze data I've never, quote, had my hands on. And, there's a few reasons for this. One, it ensures privacy and security of the data. And not to diminish the value of the analytics relative to the data, but we've got to prevent data misappropriation. And another practical reason for this is data are just too big to move around and put onto a laptop with a terabyte hard drive. And so the analytics seem to be more efficient to move them around than it is the data. Well, along those same lines, one of the things I always challenge my graduate students. So the graduate students out there or professors working with students, this is something I want you to pass on to them. Consider how to analyze data that you've never had your hands on. And students, how think about what you're really good at. You tell me that you're an excellent applied economist, analyst, data scientist, data engineer, whatever we're calling ourselves today. How can you replace yourself with an algorithm? So well, that's not important. Well, if what you do is so good and important, someone else will replace you with an algorithm if you don't do it yourself first. So that's something to keep in mind. Again, about a decade ago or 13 years ago, we submitted this patent application for automated analysis of spatial data. And I'm not listed as the inventor. And this has not been greatly used. I get a lot of feedback from groups saying that our customers will not pay for these bells and whistles. Okay, that's fair enough. So, because analysts are really expensive, how can we replace analysts in interpretation with algorithms that can work at near zero marginal costs? And that's going to be the one of the challenges as we move forward into the future. And as we move into the future, I get a lot of questions about what are we going to look like? Well, today we have a lot of different groups who are vying for data coming from farmers' fields. And we have sort of a disproportionate number of farmers who are contributing data. So, summing up some of the things we talked about today about empowering farmers with on farm experiments, one, the profitability is going to differ for each grower. Jess Longboard DeBoer talked a little bit about the human capital aspect. And he's also been quoted as saying that the economics of precision agriculture are site specific. It matters about where and when and what the product. But we also want to consider the who. Human capital requirements are really important here. And the valuations are often misunderstood because we do not put a lot of emphasis on the skill sets that we need to manage data, to analyze data, to interpret results from analysis. And these are the reasons I'm talking about automating the process to remove the requirement for that human capital. The next generation, Generation Z, the oldest members of this generation are about college age right now. They will operate farms entirely different than baby boomers, and their tolerance for getting things to work will be much lower. They're going to expect things to be instantaneous and work right the first time. If not, they're going to move on. And so those of us who are developing tools and manufacturing tools need to be ready for a different group of customers and clientele. Automation, I want to emphasize that. The remaining tedious tasks that I just mentioned are required in order to create value from on-farm experimentation, whether the value is within the farm gates, beyond the farm gates, how it's shared among different groups. Automation will be very important as we move forward. Again, I am Terry Griffin. I'm with Kansas State University.